This is section 12.5, the binomial theorem. We're going to go ahead and define what a binomial is, and then we're going to talk about the binomial coefficients. So an expression such as a plus b is called a binomial. And when we square a binomial, we multiply that binomial by itself, and then we multiply those two binomials together, we come up with this trinomial. Of course, there's many ways you can distribute this a to both terms and then distribute this b to both terms if you'd like. You can do that. So you'd have a squared plus ab plus ab plus b squared, and here is the 2ab. Okay. So when we square a binomial, we have an expression that's called a binomial expansion. And when we expand several powers of a plus b and note patterns, when we do that, we'll see something like this. So anything to the 0 power is 1. A plus b is just equal to a plus b. And then we just talked about squaring that binomial and cubing, raising it to the 4th power and raising it to the 5th power. And notice these coefficients, 1, 1, 1, 2, 1, 1, 1, 1, 2, 1. And so we have 1, 3, 3, 1 once they're simplified, and so forth. From the expansion of a plus b to the nth power, we note that the exponent on a decreases from n to 0 on sequential terms from left to right. The exponent on b decreases from 0 to n on sequential terms from left to right. And the sum of the exponents on each term, which is also known as the degree of the term, is n. The number of terms in the expansion is n plus 1. For example, here n is 1 and we have 2 terms. Here n is 2 and we have 3 terms. So that's what this means. For example, the expansion of a plus b to the 4th power has 5 terms. The coefficients for the expansion of a plus b to the nth power follow a triangular array of numbers called Pascal's triangle. Each row begins and ends with a 1. So note, 1 and 1. And each entry in between is the sum of the 2 diagonal entries from the row above. So here you can see 1 plus 2 is 3, 2 plus 1 is 3, 1 plus 3 is 4, 6 plus 4 is 10, and so forth. So let's expand a plus b to the 7th power. So we already know that we will have an a to the 7th term. And let me write this below because this is going to be a little bit long. So we will have a to the 7th plus a coefficient a to the 6th times b plus a coefficient. Now we're going to drop down a to the 5th and b is squared. Again, here n is 7. So 5 plus 2 is 7. So you can see that these powers will add up to n plus, you guessed it, a to the 4th b cubed, a cubed, b to the 4th, a squared, b to the 5th, a, oops, I forgot my underline, a, b to the 6th, plus b to the 7th. See if I can move that over just a touch. and then maybe make it a tad bit smaller so I fit it in there. Okay, let's find our coefficients using the triangle. So if we have a 1 and a 1 and a 1, we know that we have a 2 here. And then we have another 1 and a 1. So this is a 3 and a 3 and another 1, and so forth. And we could keep going. And we need to get to 7. So let me see if I can make that a tad bit smaller. And finally, we get to the 7. And that 7 is what we were looking for right here. Whoops. And so now we have our coefficients. So we can fill these in with a 7, 21, 35, 35, 21, 7, and a 1. And we will have a 1 here. And we knew this was going to be a 1, so I probably could have just put b to the 7th. Okay, so that expansion of a plus b to the nth power works really nice when we can create that triangle, Pascal's triangle. Okay, coefficients of binomial expansion. We're going to let n and r be non-negative integers, and n is greater than or equal to r. So this expression, n choose r, looks like this. N choose r. And that's a binomial coefficient, and this is what it's defined by. N factorial divided by r factorial multiplied by n minus r factorial. So let's do a few of these by hand. So we have 4 factorial. 4 minus 2 is 2 factorial. Whoops, that's r. And then n minus r, 4 minus 2 is another 2 factorial. And that comes out to 6. Let's try this one. 10 factorial, you'll write your r factorial, then you'll subtract them, and this is 120. Let's try this again. 10 factorial over 3 factorial, 7 factorial, and that just looks like number 3. This is 5 factorial over, remember, 0 factorial is equal to 1, and so is 1 factorial, okay? And then 5 minus 0 is 5 factorial, and you guessed it, that's just equal to 1. Let's try 5 choose 5. That's 5 factorial over 5 factorial, and then 5 minus 5 is 0. So we have 0 factorial, and that's also equal to 1. So let's apply the binomial theorem. Let n be a positive integer. The expansion of a plus b, so this binomial to the nth power, is given as n choose 0 times a sub n choose 1 times a sub n minus 1, b to the first power. So you can see the degree of a is descending, the degree of b is ascending until you reach b to the n power. And here you can see the binomial theorem with summation notation, sigma notation. So let's give it a try. We're going to expand 3y plus 2z all raised to the 5th power. So we're going to 5 choose 0, and we're going to have 3y all to the 5th power. Now we will have 5 choose 1. This time 3y is to the 4th power, and we're going to have 2z to the 1st power, and so forth. And I'm just going to continue on this line. So now we have 5, choose 4. 3y is just raised to the first power now. And 2z is raised to the fourth. And then we have 5, choose 5. And we've already talked about that's going to be equal to 1. And then we have 2z raised to the fifth power. So now you can see that 5, choose 0 is 1. And 3 to the fifth power is 243, y to the fifth. And then we'll have 3 to the fourth times 2 times 5, choose 1. And you can figure that out with your calculator, or you can do them by hand. And we'll just keep going. And you can always pause the video and see if you get these values that I got. 32z to the fifth. So it's very easy to use the binomial theorem. And let's try one more. We're going to expand y squared minus 5z to the fourth power. So we'll begin with y squared to the fourth power. Of course, that's 4, choose 0, but we wouldn't write that. Plus 4, choose 1, y squared, all cubed, times negative 5z to the first power, and so forth. And we'll square negative 5z. And I may have just enough room to have negative 5z to the fourth power. So if you take some time and you multiply these out, you will see here we'll have a negative because of that negative 5z. So 20y to the sixth, z to the first. And you should come up with 150 y to the fourth, z squared. So really nice. We will now end this section with finding a specific term. So we'll be finding a specific term in binomial expansion. So we'll consider the first 4 terms of the binomial expansion of a plus b to the n. Looking at this pattern, you can see 0, 1, 2. The power, the degree of b is increasing, and the degree of a is decreasing. These lower values match the exponent on b. Those match the exponent on b. Okay, so the kth term of binomial expansion is n choose k minus 1, and then we have this power of a, which is n minus k minus 1, and b is raised to the k minus 1. So let's give this a try. Find the 7th term. So k is equal to 7. That's what we're looking for, of the expansion of x minus 3y all to the 9th power. So n is equal to 9. So with that, the 7th term is going to be 9 choose 6. And that's because, well, we'll write these first. We have x to the 9 minus 6 and negative 3y to the 6th. And why don't I put this out? Why don't I write this formula first? Let's do this formula first. So we'll have n k minus 1, a to the n minus k minus 1, b to the k minus 1. I think that would be better. So remember that n is 9 and k minus 1 is 6. And then we have 9 minus 7 minus 1 and b to the 7 minus 1. So 9, choose 6, a. And so that's really 9 minus 6, which is a cubed. And I guess I should be writing an x here, sorry. And this should say negative 3y. I was trying to write the formula, and then of course, and then that would be to the k minus 1, so that would be to the 7 minus 1 power. So now we have x to the 6th power and negative 3y to the 6th power. Whoops, that's 3. 9 minus 6 is 3. And if you work that out, you will get 61,236 x cubed y to the 6th power. That is the 7th term. And that concludes this video.